This video discusses the procedure for the common gases experiment for general chemistry at Madison College. For this experiment, you're going to be doing 5 different reactions, and each reaction that you do is going to produce a gas as one of its products. In this video, I'm going to discuss the reagents that you use and the setup that you use for each reaction separately. So to start off, I'm going to be talking about reaction A. Reaction A uses nitric acid, and you'll find the nitric acid in the fume hood. This reaction produces a toxic gas. It's really important that you don't try to detect the odor of this gas, and that's why you want to set up the reaction in the fume hood in the lab. This is the only reaction that you're going to be setting up in the fume hood. The procedure talks about using 1 milliliter of the nitric acid. And the nitric acid, you don't need to measure it out precisely. You could just use 1 squeeze on the dropper on the top of the bottle in the fume hood. You just need enough nitric acid to completely submerge the copper metal. The copper metal is your other reactant, and you'll see that the copper will be in a plastic container in the fume hood. You'll want to use your tweezers to add a piece of copper metal to that 1 squeeze of nitric acid in your labeled test tube. And just remember that you're going to be setting up all of this in the fume hood in the lab. Once you've added the copper metal, you want to seal the test tube. And what we use to seal the test tube is what's called parafilm. And you'll see that there's a plastic container of parafilm in the fume hood. And it has a paper back where it says the word parafilm on it. You want to take the paper off of the parafilm, and it's actually just a stretchy plastic that you can use to stretch and seal over the top of the test tube, like you can see in the picture here. You'll want to leave the reaction in the fume hood for 5 to 10 minutes and then observe the gas that's produced. Because the gas that's produced in this reaction is toxic, you definitely don't want to detect the odor of it. We're also going to clean up this reaction for you. So you don't have to clean up your test tube for reaction A. Just leave it in the fume hood and we'll clean it up for you after the lab. Restock your drawer with a clean test tube. You'll see that there's a bin that's labeled in the fume hood with clean test tubes, and you can just take a clean test tube to replace the one that you used for reaction A. The next reaction that you're going to be doing, reaction B, uses hydrochloric acid. Again, you just need to use 1 squeeze of the hydrochloric acid. With the nitric acid and the hydrochloric acid, they're both corrosive solutions, and you want to be careful when you're using them. You want to get 1 squeeze of the hydrochloric acid. Your other reagent is sodium bicarbonate, and sodium bicarbonate is a solid. You want to go over to the balances in the lab, and you'll see that there's a plastic container labeled sodium bicarbonate, and you want to weigh out about 0.4 grams of that. There'll be a labeled scoop along with the sodium bicarbonate, and you can use a plastic weigh boat to weigh out the sodium bicarbonate in. Before you add the sodium bicarbonate, you want to prepare wet litmus paper. So one of the tests that you do for reaction B is what we call a wet litmus test. And it's a way to test whether a gas is acidic, basic, or neutral. And you can do this test for any gas that's soluble in water. You want to wet the litmus paper so that it can interact with the gas that forms in reaction B. And you can just wet that with deionized water. You're going to take the wet litmus paper and you want to position it at the end of a metal spatula that's in your drawer. You can use the metal spatula to insert it into the top of test tube B once you have the reaction going. So get this all set up before you even start the reaction so you're ready to do your litmus test right away. When you're ready and you have your wet litmus paper ready, you can then pour the sodium bicarbonate into the hydrochloric acid that's in test tube B to start your reaction. To interpret the results of your litmus test, you're going to be looking for a color change on the litmus paper. It's purple to begin with when you get it out of the bottle. If it turns pink, then you would say that the gas is acidic. If it turns blue, you would say that the gas is basic. And if it doesn't change color, if it stays purple, you would say that the gas is neutral or that it's just not soluble in water. The other test that you're going to be doing for reaction B is a splint test, and you've done a splint test before in the observations experiment. So you want to get a wooden splint and a box of matches. You use the splint test to test whether a gas is flammable or not. The two things that you're looking for is you're looking to see if the splint stays lit, in which case you would say it's a flammable gas. If the splint goes out, you would say that the gas is not flammable. But what I want to talk about today with the splint test is that there's another possibility, and that's when you hear a loud pop in the splint test. Sometimes when you take a lighted splint and you put it into a gas, you'll hear a really loud pop. What I want you to think about when you hear that loud pop is that it's a mini explosion. If you hear a loud pop, that indicates that the gas is very flammable. It reacts quickly, which is the pop, and once it all reacts, you tend to see that the splint goes out. So be really careful to listen for that pop, because sometimes people mistake it as being on a gas that's not flammable when they see that the splint goes out. So you'll do a splint test as an additional observation for the gas in reaction B. When you're all done with reaction B, you can rinse the contents from that test tube down the drain. The next reaction that you're going to be doing, reaction C, you need to weigh out ammonium chloride. And ammonium chloride is a solid, so you'll find a labeled bottle by the balances and a scoop to go along with it. You want about 0.5 grams of the ammonium chloride, and you can weigh that into a plastic weigh boat. You want to dissolve the ammonium chloride in deionized water. Measure out 5 milliliters of deionized water in a small glass graduated cylinder. Add the solid ammonium chloride into your labeled test tube, and then add the 5 milliliters of deionized water to dissolve the solid. Use a glass stir rod from your drawer to mix that up so that all of the solids dissolved. To initiate reaction C, you want to heat it up. So you're going to want to get the hot plate that's in the cabinet underneath the sink in lab and get about 75 milliliters of tap water and put your test tube for reaction C into the water to heat it up. I would suggest setting your hot plate at about 5 or 6. You don't want it to get so hot that the water is boiling. You just have to heat it up a little bit. Once you have your ammonium chloride dissolved in water and heating up, to that you want to add 10 drops of sodium hydroxide. And the sodium hydroxide is a solution, and you'll find it in a clear bottle with a dropper on the top. You want to add 10 drops of the sodium hydroxide to test tube C and then mix it with a glass stir rod. What you're really trying to detect for the gas that forms in reaction C is the odor of the gas. It can be hard to detect the odor of the gas, and one trick that you can use is to take the glass stir rod and insert it in the test tube, pull it out, and then try to waft or detect the odor from the glass stir rod. If you still can't detect the odor of the gas, talk with your instructor. You can always add additional drops of sodium hydroxide, and you might need to heat up the reaction more in order to detect the odor for the gas that forms in reaction C. The other observation that you're going to make is you're going to do a wet litmus test. So again, you'll want to wet some litmus paper and position it on your metal spatula to insert it into the headspace of reaction C. And you'll be able to test whether the gas that forms is acidic, basic, or neutral with your wet litmus test. When you're all done with your observations for reaction C, the contents of that, you can dump that down the sink in lab and wash out the test tube to clean up. The next reaction that you're going to be doing, reaction D, uses hydrogen peroxide. Hydrogen peroxide is a solution that you might be familiar with. It's something that you might find in a first aid kit. You can use it to clean out cuts. You'll find it in a brown glass bottle in the lab. You want to measure out 5 milliliters of the hydrogen peroxide and pour it into your test tube labeled D for reaction D. To initiate the reaction, you're going to want to use manganese dioxide. And the manganese dioxide is a gray, shiny powder. It's a solid, and you'll find it in a brown container in the lab. You don't need to weigh this out precisely, you just need a small scoop of the manganese dioxide, so about the size of a grain of rice. And you'll see that there's a labeled scoop in the lab for you to use. Once you add that small scoop of manganese dioxide, you want to seal the top of the reaction to trap the gas that forms. So you're going to seal it using that stretchy plastic, the parafilm, like you used in reaction A, and seal the top of the reaction and wait 5 minutes. The other test that you're going to do for reaction D is what we call a glowing splint test. What's different about a glowing splint test, that instead of having a flame at the end of your splint, you want to blow out that flame so that you just see a small ember. You're going to take that glowing splint and that ember that's at the end of your wooden splint and stick it into the gas, stick it into test tube D. What you're looking for is whether a flame grows from the ember or whether it goes out completely. We often do a glowing splint test when we're trying to test for oxygen gas. Oxygen gas supports combustion. It supports that flame at the end of your splint, and that's what we're testing for in reaction D. When you're all done with your observations for reaction D, you don't want to pour it down the drain. That manganese dioxide will still be present in your test tube, and we don't want it to go down the drain and clog the drains in lab. There'll be a metal waste container in the front of the room, and you want to pour out the contents of reaction D into the metal waste container. If any of the manganese dioxide gets stuck in your test tube, use your deionized rinse bottle to rinse all of the manganese dioxide into the waste container. You can then wash out your test tube like you normally do. The last reaction that you're going to be doing is reaction E, which uses hydrochloric acid again. For this reaction, you want to measure out 5 milliliters of hydrochloric acid with a small graduated glass cylinder. And you're going to add that to test tube E. To that, you want to add a small strip of magnesium metal, and you'll find a small plastic container that has the magnesium metal in that. You want to observe for this reaction the color of the gas that forms, and you also want to do a splint test. Before you add the magnesium metal, have your partner prepare the flame, prepare a splint so that you can do the splint test right away after you add the magnesium. Like all the other splint tests that you do today, you're looking to see whether the splint stays lit or whether it goes out. Be careful to listen to see if you hear a loud pop, and remember, if you hear that pop, that indicates that the gas is very flammable. The pop represents a mini explosion where all of the flammable gas reacts quickly. To clean up, when you're finished with all of your observations for reaction E, if there's any unreacted metal, you can put it in the metal waste container. Wash the contents down the drain of the solution left over in reaction E, and you can wash out that test tube like you normally do. This is the end of your procedure for the common gases experiment. I hope this video helps you prepare for lab.